Hello students, this session will be basically targeted for the ICSE students in the subject computer application in Java. So the first program that I would like you to go through is whether the given number n is a prime number or not, whether it is a prime number or not. So there are three different ways by which we can do the same. The first way is that if a number is prime, that means that if I start dividing that number from 1 to n, and if I got two factors, exactly two factors, then the number is prime. And if I got more than two factors, that means the number is not prime. This is the first strategy which we will deal in the first video. In the second video, we will try to optimize this algorithm to get the more broader and more time limited program execution. Now, in order to write this program, what I am doing is that I am taking a variable n and I am taking an input for this. So for taking the input, what I am doing is that I am using the scanner class, creating an object of type scanner class. After that, a simple statement that will ask the user to input a number. Now, what I'm doing is that I am having an divisor I to repeat the loop and a factor f, number of factor whose initial value is 0. What I will do is that I will try to divide this n. For example, the value of n is say 21. What I will do is that I will divide 21 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 21. So the factors that I will get for 21 is one factor is 1, one factor is 3, one factor is 7, and one factor is 21. So the number of factors is 4. That definitely means that this is not a prime number. If I go for say 11, then my factors will be 1, 2, not a factor, 3, not a factor, so on, 9, not a factor, 10, not a factor, 11 is another factor. So the number of factors is what? The number of factors is 2. Therefore, my number 11 is a prime number. Okay? So, having this philosophy in our mind, we will start exploring this journey. So, what I will do is that I will have a loop. It will start with 1. It will end with n. And the total number of times the loop will iterate is I is less than or equal to n. Now, what I will do is that I will divide n with I. And if it is divisible, that is I am getting the factor, then what I will do? I will simply update the number of factors. Then I will be at the outside of the loop. Here, what I will do is that I will check whether f is equal to 2, means we are having exactly two factors. If we are having exactly two factors, that means that this number is prime number. Okay, and in all the other cases, the number is not a prime number. Not a prime number. Let's try to execute this program. For execution of this program, I have used my compiler. This is the compiler which I am using. Now, the input that I want to give is say 11. Okay, and let's check that. What is the output? The output is, one second, I have not input the variable value n. Fine, no problem. The input is 11. It's a prime number. Now what I'm doing is that I am giving the input 12. It's not a prime number. Again, we have checked for 21. Let's go for 21. It's also not a prime number. And for our simplicity, what we can do is that we can print the number of factors also. We can also print the number of factors also. So if I write here f, and here also if I write f, so we could have a more precise idea that what actually we are getting. Okay. So if again I will execute it, see the factors number is 4. If I go with 25, the factors number is 3. Therefore, it is not a prime number. If I go with 29, the factors number is 2. It's a prime number. If I go with 31, the number of factors is 2. It's also a prime number. If I go with 32, the number of factors is 6. It's not a prime number. So this philosophy logic is based on the count of the factor. What is the count of the factor? The count of the factor means in the case of a prime number, we are having 2 factors. And in the case of a not prime number, we are having more than 2 factors. Okay. Now, as I have actually committed you that I will explain 3 techniques of the same. So first, analyze that where we have actually gone wrong in this technique number 1. The simple fact that a program has 2 aspects. Aspect number 1, it should be correct. And aspect number 2, it should be perfect. Perfect means the number of times the program is executing should be at least as possible. Means my target should be that the number of time the program is actually executing should be at the minimal. But if I compare with this technique, this technique, in this technique, the program is correct and you all will get marks for this program. You all will get marks for this program. If the question is of 3 marks, you will get 3 out of 3. But I think that you should know to actually upgrade the concept of the program, the logic of the program. So first, the defect. Defect is that for checking the primeness of number n, the number of times the loop is executing is n. So if the value of n is 10, then the total number of time the loop is executing is 10. If the value of n is 100, the total number of time the loop is executing is 100. As the value of n grows, the number of time the loop is executing also grows. Is any way to solve this? Yes. See, if I have a number n, and if the value of n is say 100, what is the maximum factor that can I expect from 100? The maximum factor that can I expect with 100 is 50. That means from 1 to 50, all the factors can be there. And if I cross 50, that is 51, onwards 99 and 100, the number of factors is not there between 51 and 99. So let's change the concept. Let's try this. We will start to divide n not with 1, start with 2, and will not end at 100, will end at 50. This is the perfect zone of finding a factor. Because if there is a factor, it would be between 2, 2, and by 2. This is the perfect range for factor. This is the perfect range for factor. The factor will reside within this range only. The factor, the true factor cannot be more than n by 2, and we cannot consider 1 as a factor because it is a factor for both prime number and a factor for both not a prime number. So what I will use the trick is that I will slightly modify this program. Slightly. What I will do is that in place of f is equal to 0, I will write int f is equal to 1. Means f1 means prime and f0 means not prime. Here I have considered the fact that f1 means prime and f0 means not prime. Okay, f1 means prime and f0 means not prime. Okay, now what I will do is that I will start this journey with I is equal to 2. I will end this journey at n by 2. If the factor is there, in place of adding, what I will do, I will make this f to 0, means not prime, and I will make this the end statement, because if it is divisible, factor is there, then no need to divide and check again. Break means to terminate. Now we are having two values, either f1 or f0. 1 means it is a prime number. 0 means it is not a prime number. Okay. Now here in place of writing this, what I will do is that I will write f is equal to 1. That means if it is divisible, then f0 not divisible, f1 means prime number. And if the value of f is not 1, anything other value, then it is a not a prime number. Okay, let's check this one. What I will do is that I will run this program with say 21. What I will get is that it's not a prime number. Okay, it's not a prime number. And why? Because the value of f is 0. 0 cup when will be 0? When it is divisible. Again, I will go for f is equal to 19. N is equal to 19. It is not divisible. Since it is not divisible, therefore the value of f is retained as 1, and this is a way by which we can actually check the primeness of a number with the total number of times my loop is executing is n by 2. Initially it was n, and in my second video what I will do, I will further reduce this is number of instruction to a greater level. Okay, thanks, bye bye.